resistors in parallel. Let us consider three resistors which are connected in parallel. It is R1, R2, R3 across voltages of V volts. Here the total current passing through the circuit, let take it as I, and the current passing through the R1 V I1, let R2 be I2, let R3, the current passing through R3 be I3. Next, we take voltage across R1, let it be V1, voltage across R2 would be V2, and voltage across R3 be V3. Now the equivalent circuit of these three resistors connected in parallel is taken as like this. This is R equivalent, and which is connected across the same voltage source V volts, and the same current, total current will pass into this equivalent circuit, that is I. Here this small circuit with R equivalent is the equivalent of these three resistors connected in parallel. Next, in parallel circuit, the current passing through the, here in parallel circuit, current, that is the total current in the circuit, that is I, is equal to the sum of the individual current passing through the elements, that is I1 plus I2 plus I3. The total current I in the circuit is equal to the sum of the individual currents passing through the elements, that is I1 plus I2 plus I3. Here I1 is the current passing through R1, I2 is the current passing through R2, and I3 is the current passing through R3. Here total current I is equal to current passing through the sum of the current passing through the individual elements, that is I is equal to I1 plus I2 plus I3. Next, in parallel circuit, voltage across all the elements is same, that is V, voltage across resistor R1, that is V1 is equal to voltage across resistor R2, that is V2 is equal to voltage across resistor R2, that is V3 is equal to applied voltage, applied voltage or supply voltage. In parallel circuit, current divides voltage same. Okay, earlier we observed in series circuit current is same, voltage divides, but in parallel circuit current divides, voltage is same. Voltage across all the elements is same. Let it be V, that is supply voltage V, and the total current is the sum of the individual currents passing through the elements in the parallel circuit. Next, here by applying Ohm's law to this circuit, what we get, V is equal to I into R equivalent. V is equal to I into R equivalent. From this expression, I is equal to V by R equivalent. This is expression 1. By applying Ohm's law to this circuit, we get V is equal to I into R equivalent. From this expression, I is equal to V by R equivalent. Now, we are applying Ohm's law to the individual elements which are connected in parallel in this circuit, that is Ohm's law applied to the resistor R1. In the sense, it should be V1 is equal to I1 R1. V2 similarly, from Ohm's law, it is applied to the resistor R2. That is, apply Ohm's law to each resistance. We get V1 is equal to I1 R1, V2 is equal to I2 R2, and V3 is equal to I3 R3. But what we know that V is same, that is voltage across all the elements is same, and that is V. In place of V1, V2, V3 we may write V. Then it is V is equal to I1 R1, V is equal to I2 R2, and V is equal to I3. From this expression, I1 is equal to V by R1, and from this expression take it as I2, take it out, and I2 is equal to V by R2, and this expression I3 is equal to V by R3. Now substitute I1, I2, I3 here in this expression, that is I is equal to I1 plus I2 plus I3. We may get I is equal to I1, in place of I1 we may write V by R1 plus I2 V by R2 plus, in place of I3 we may write V by R3. Now we take it as common, it is 1 by R1 plus 1 by R2 plus 1 by R3. This is expression number 2. By comparing expression 1 and 2, expression 1 and 2, we get, by comparing these two expressions, we may get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. Similarly, from this expression, if n number of resistors connected in parallel, in the sense 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus, and so on, plus 1 by Rn. From parallel circuit, what we observe is the total current passing through the circuit is equal to the sum of the individual currents passing through the resistors or elements. And one more thing we observe here in this parallel circuit is voltage across all the elements in parallel circuit is same, and equivalent resistance, that is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Next, if two resistors, that is R1 and R2, are connected in parallel, in the sense, that is, see here, this is R1, R2, this is total current I, this is I1. If two resistors R1 and R2 are connected in parallel, in the sense, from this previous expression, we get 1 by R equivalent is equal to 1 by R1 plus 1 by R2. By simplifying this, 1 by R equivalent is equal to R1 R2 by R2 plus R1. Okay, LCM. R1 R2 plus R2. From this expression, R equivalent is equal to inverse of this, that is no self 1 by R equivalent is R equivalent. This is the no self, that is reciprocal of this. This is R1 R2 by R1 plus R2. That is, if two resistors are connected in parallel in the sense R equivalent is equal to R1 into R2 by R1 plus R2. That is product of two resistance values divided by sum. Very important one. If two resistors are connected in parallel resistance, we directly write R equivalent is equal to R1 R2 by R1 into R2 by R1 plus R2. That is product of those two by sum of those two resistance values. For suppose if two resistors connected in parallel with equal resistance value, that means R1 is equal to R2 is equal to, let R say R, means two resistors are connected in parallel with equal resistance value, that is both are connected with the same resistance value. It is R and another one resistance R connected across the voltage V volts, same total. This is the total current. Now R equivalent is equal, see here, if two resistors are connected in parallel in the sense, that is R equivalent is equal to product by sum, that is R1 into R2 by R1 plus R2. But what we observe here in the circuit, both the resistance are with the same resistance value, that is R into R by, in place of R1 or in place of R2 we may write R, that is R plus R, it is equal to R square by 2R. Okay, R get cancelled, then it is R by 2. Therefore, if two resistors connected in parallel with equal resistance value, that is R equivalent becomes R by 2, that is half of that value. For suppose if two resistors are connected in parallel with equivalent resistance of 10 ohms, then what is R equivalent? It is half of this, that is 10 by 2, it is 5 ohms. If two resistors are connected in parallel in the sense, what is the equivalent resistance? It is half of that. Two resistors are connected in parallel with same value, in the sense R equivalent is half of that value. Okay, this is the example. Okay, simply by observing this, okay, resistance of 10 ohms of two values, same value connected in parallel in the sense R equivalent is half of that value, that is 10 ohms, that is 5 ohms.